All right, we're going over the last section of the object-oriented section of the Rust programming book. And that is implementing an object-oriented design pattern. Oh, state pattern. Ooh. The state pattern is an object-oriented design pattern. The crux of the pattern is that a value has some internal state, which is represented by a set of state objects, and the value's behavior changes based on the internal state. These state objects share functionality. In Rust, of course, we use structs and traits rather than objects and inheritance. Each state object is responsible for its own behavior and for governing when it should change into another state. The value that holds a state object knows nothing about the different behavior of the states or when to transition between states. So here is just going over the definition loosely of what the state pattern is, and it is the ability for like an object to hold some internal state, and these states and the internal state can go through various states, and each state can have a method or some sort of property on it that is inherent to that specific state, and it also knows when to change states to go from state A to state B to state C. Using the state pattern means when the business requirements of a program change, we won't need to change the code of the value holding the state or the code that uses the value. We only need to update the code inside one of the state objects to change its rules, or perhaps add more state objects. Let's look at an example of the state design pattern and how to use it in Rust. So here they're going over at least up to about, there. Some of the benefits of using the state pattern is that when the business requirements change, you don't have to touch everything in your code base. You just have to touch the states, or at least the state that is affected. You may be updating a state, you may be removing a state, you may be adding states. But if you're using the state pattern, that is mostly what you're doing in terms of how to change things to fit new requirements for the state pattern. We'll implement a blog post workflow in an incremental way. The blog's final functionality will look like this. A blog post starts as an empty draft. When the draft is done, a review of the post is requested. When the post is approved, it gets published. Only published blogs return content to print, so unapproved posts can't accidentally be published. Alright, so we're creating blog functionality, and we have the state of seemingly a draft, something that needs to be approved, and then after it gets approved, it gets published, and then only things that are published can be printed. Any other changes attempted on a post should have no effect. For example, if we try to approve a draft blog post before we've requested a review, the post should remain an unpublished draft. I see. So here's just basically stating that the states and the transitions should be very strict, so you shouldn't be able to skip any. It's going straight down this line. Listing 17-11 shows this workflow in code form. This is an example usage of the API will implement in a library crate named blog. This won't compile yet because we haven't implemented the blog crate yet. Are we going to implement the blog crate? Hold on. Seemingly. I'll come back to it because I'm not sure if I should write this yet. But let's read through. We have our main. We're importing post. And basically what we want to be able to do is say create a post, add text to the post, request a review of the post, and then approve the post. So seemingly creating an empty draft, we're adding content to said draft, requesting it for approval. Once it's approved, it's now published. We want to allow the user to create a new draft blog post with post new. Then we want to allow text to be added to the blog post while it is in a draft state. If we try to get the post content immediately before approval, nothing should happen because the post is still a draft. We've added assert equal in the code for demonstration purposes. An excellent unit test for this would be to assert that the draft blog post returns an empty string from the content method. But we're not going to write tests for this example. So let's go back up here real quick. So what they're saying is, at this point we created an empty draft. At this point we added text to the draft. Because the draft is not published, we should not be able to get the content. So here's the check. We did a post that content. Even though the draft has content, it's going to come out nothing, empty string. Same thing what happens when we get to the review state. It's the draft is now being requested for review. So this is another state. And when we do post that content, because it is not published, we should get 0 content. And then post the post being approved, now it's in a published state, we should be able to get the content, which is I ate salad for lunch today. Next, we want to enable a request for review of the post, and we want content to return an empty string while waiting for the review. When the post receives approval, it should get published, meaning the text of the post will be returned when content is called, which is what we just went over. Notice that the only type we're interacting with from the crate is the post type. This type will use the state pattern and will hold a value that will be one of 3 state objects representing the various states a post can be in: draft, waiting for review, or published. Changing one state to another will be managed internally within the post type. The states change in response to the methods called by our library user on the post instance, but they don't have to manage the states directly. Also, users can't make a mistake with the states, like publishing a post before it's reviewed. So what they're stating here is that in terms of the user interface, this is what the user sees. However, internally, we know that their post is handling its own state. So as we were saying earlier, post new creates a new state of an empty draft, which is still a draft. You can add text to a draft. But once we hit the request review, we switch to a new state, which is, I guess, pending for review or requesting a review. And then when we hit post.approve, we go to another new state, which is published. So the user's indirectly controlling the states by using the appropriate methods, but the post itself is internally handling the state itself. Defining post and creating a new instance in the draft state. Let's get started on implementation of the library. We know we need a public post struct that holds some content. So we will start with the definition of a struct and an associated public new function to create an instance of post as shown in listing 17-12. We'll also make a private state trait. Then post will hold a trait object of box dynamic state inside an option T in a private field named state. You'll see why the option T is necessary in a bit. So let's read through this, and this part I think I can write. So we have public struct post, state option, box dynamic state. So we have our trait object, which is an option because it may not exist. Content string, and implementation for a post, and we have our associated function of new, which creates a new post. And when we create a new post, we have an empty draft. And then state is a trait defined here, nothing associated with it, but it's there. And here's draft, nothing there yet. And we implement state for draft. And that is why we can have our dynamic object here of draft. Okay, that makes sense. Let's write that out. And let me open my editor. I don't need you anymore. So we read through this and it makes sense. I'm just going to copy and paste it. lib.rs, cool. And it's in the right place. The state trait defines the behavior shared by different post states, and the draft, pending review, and publish states will all implement the state trait. For now, the trait doesn't have any methods, and we will start by defining just the draft state because that is the state we want a post to start in. When we create a new post, we set its state field to some value that holds a box. This box points to a new instance of the draft struct. This ensures whenever we create a new instance of post, it will start out as a draft. Because the state field of post is private, there is no way to create a post in any other state. In the post new function, we set the content field to a new empty string. Which, yes, they're describing this essentially, and they're saying that there's only one way to create a post, and that is via this function. There's only one way to create a new post, and each new post is always going to start with an empty draft, and a content being an empty string. Storing the text of the post content. Listing 17.11 showed that we want to be able to call a method named add text and pass it to the reference string that is then added to the text content of the blog post. We implement this as a method rather than exposing the content field as public. This means we can implement a method later that will control how the content field data is read. The add text method is pretty straightforward. So let's add the implementation listing 17-13 to the implementation post block. And here is the block, but hold on, I'm getting a sense of what we're doing now. Let's go up here to the first block of code. We are creating this API, and in this API we see the new, which we already wrote, right? Add text, which implies that we are adding text to the private state of context via this method. So this has to be created. Seemingly, we're also going to have, at some point in time, create a request, review, and approve. The reason why I came back here is just to note the add text, where we got it from, and why it's needed. So this is needed so it can add text to the context, the private field. But also we have content here, which is seemingly just a read method for what the content is. And we're controlling the state there. It's not directly a read method. Seemingly it's based on the state that we have. But we'll get to that. So post, we're implementing the add text, which is just pushing text to the string. That makes sense. We can add that now, actually. Really straightforward. Post new. The add text method takes a mutable reference to self because we're changing the post instance that we're calling add text on. We then call push string to the string in content. I kept saying context, content. And pass the text argument to add to the saved content. This behavior doesn't depend on the state the post is in, so it is not part of the state pattern. The add text method doesn't interact with the state field at all, but it is part of the behavior we want to support. Okay, so they're noting what add text does and pushes text to string, but they're also noting that it's not a part of the state pattern, like explicitly. However, it does add to the behavior that we want to support. Ensuring the content of a draft post is empty. Even after we've called add text and added some content to our post, we still want the content method to return an empty string slice because the post is still in the draft state, as shown in line 7 of listing 1711. For now, let's implement the content method with the simplest thing that will fulfill this requirement, always returning an empty string slice. We'll change this later once we implement the ability to change a post state so it can be published. So far, post can only be in the draft state, so the post content should always be empty string. Listing 17-14 shows this placeholder implementation. Okay. So here they're noting the behavior of the method content, and as shown in the block of code that we first saw, as long as the state is draft, well, as long as the state is not published, as in if the state is in draft or pending for review, whatever that state name is, we haven't really gotten there yet, the content method to return an empty string. And since we haven't implemented transitions yet, and we also haven't implemented the published state yet, the simplest code that we can write at this point in time is having the content method return an empty string always, because as of right now, based on what we have, that is the only thing that we want it to do. So down here we see a public function, a public method called content that returns an empty string, and we're adding that to our implementation block. With this added content method, everything in listing 17-11 up to line 7 works as intended. So what they're saying here is, now let's go back up to this listing. Everything in this up to line 7 should work. So 1, 2, 3, 4, 5, 6, 7. So everything up to here pretty much, because here we start changing. We change state, but we also haven't implemented request underscore review yet. So everything from here upward should work. Requesting a review of the post changes its state. Next, we need to add functionality to request a review of a post, which should change its state from draft to pending review. Listing 17-15 shows this code. Alright, so let's look at this real quick. In the implementation block of post, we have a public method called request review. Takes immutable self because it's going to change the state on self. If let some self.state.take self.state equals some s.request review. So here we see that it's setting the state to the next one, and state is an option, as we see here. That's why it's within a sum. S.request review method seems to find what the next state is and then return it. Let's see. So we have our trait state, which now we have a method within this trait called request review. It takes a box of self and then returns a new state. Okay. And we have draft. Draft has an implementation of request review, and we see that it explicitly returns the next state, which is pending review. And pending review is now defined here. And it implements state. That's why it's satisfied as a trait object. And as of right now, because pending review also has to implement state, so it has to return a state, it's returning itself. So as of right now, in order for it to implement the state trait, it has to return a state, and the only one it can return without going backwards in time is itself. Okay, so this makes sense. Let's add it. Copy put this here. Where's state? I can just replace that. I could replace all of those actually from here. We give post a public method named requestReview that will take a mutable reference to self. Then we call an internal requestReview method on the current state of post. And the second requestReview method consumes the current state and returns a new state. We've added the requestReview method to the state trait. All types that implement the trait will now need to implement the requestReview method. Note that rather than having self or reference to self or mutable self as the first parameter of the method, we have self box self. This syntax means the method is only valid when called on a box holding the type. This syntax takes ownership of box self and validating the old state so the state value of the post can transform into a new state. I see. Okay. So this might be the reason why we have to use box. So let's just take a step back. So actually I have it over here. So they're saying here that we need to note that requestReview in the state, this method right here, takes self as a box self. So the only time this is satisfied is when self is wrapped in a box. And the reason they do that is because it takes ownership of the box and then it consumes it, so then it can be dropped out of memory, and then it replaces the box with a new box state. An example of that is seen here. So we consume box self. At the end of the scope, it should be dropped out of memory, and then we're returning this new box to be our state. And as you can see here, that means state is now being replaced and the old state is also being removed, like completely. To consume the old state, the requestReview method needs to take ownership of the state value. This is where the option in the state field of post comes in. We call the take method to take the sum value out of the state field and leave a none in its place, because Rust doesn't let us have unpopulated fields in structs. This lets us move the state value out of post rather than borrowing it. Then we'll set the post state value to the result of the operation. This is actually really important. This is actually telling us right here why we need the option. They're seemingly doing a switcheroo. So for Rust, when you have a struct, the field has to have a value associated with it. And currently, our post has an option that has the state. Like we create a new post, it has draft. Our ownership of that state belongs to post. But in order to have it dropped out of memory, we need to take that ownership away from the post so it can be dropped someplace else, or at least dropped in the requestReview method that we have. We do that by calling self.take or self.state.take. And what that does is it does a switcheroo. It takes the value outside of the box. It takes the value from within the box and then replaces it with none, which is a valid option. And now that the ownership of the inner state is no longer associated with post, we can do stuff to it and then drop it, which happens in the requestReview. So going on to the next paragraph, we need to set state to none temporarily rather than setting it directly with code like self.state equals self.state requestReview to get ownership of the state value. This ensures posts can't use the old state value after we've transformed it into a new state. So I guess that's another caveat. If we didn't do it this way and we did something like this, then there may be a way that posts could retroactively go back and get access to the old state. So yeah, basically what I was saying up here, in order to make sure that state gets dropped completely, we need to do the take and the switcheroo. The request review method on draft needs to return a new boxed instance of a new pending review struct, which represents the state when a post is waiting for a review. The pending review struct also implements the request review method, but doesn't do any transformations. Rather, it returns itself, because when we request a review on a post already in pending review state, it should stay in the pending review state. I see. So earlier I was wrong. So coming down here, the request review, when we call request review on a state that is already pending for review, it should just return itself, because that's not the method to move it on to the next state. So that's why this is self. My apologies. Now we can start seeing the advantages of the state pattern. The request review method on the post is the same no matter its state value. Each state is responsible for its own rules. We'll leave the content method on post as is, returning an empty string slice. We can now have a post in a pending review state as well as in a draft state, but we want the same behavior in the pending review state. Listing 17-11 now works up to line 10. And 17-11, let me scroll all the way up real quick. That is this. So now what they're saying is we've implemented the request review, and this still works as is, because for requested review, if you're in a pending state, we still want the content method return empty string. So now we have this example working all the way up to this line. So next we need to do the post approve and I guess change content method a little bit. All right, let's go back down. Adding the approve method that changes the behavior of content. The approve method will be similar to the request review method. It will set state to the value that the current state says it should have when that method is approved, as shown in listing 17.16. Let's read through this real quick. We have a public method approve, and it's doing the same trick. We do the self.state.take to replace it with none, and we're calling s.approve, which is a new method on our trait. And here we have it right here. It takes a reference to box self and returns box dynamic state, which is a trait object. And we have draft. Draft has to implement state, which means it has to implement both request review and approve, those two methods. For approve, we're returning self, which makes sense. If you call approve on a draft, nothing should change because it's still a draft. You can't skip a step, which was stated earlier in this section. So on pending review, if you call approve, we're now returning a new state, which is the published state. And we have our new published struct here, implement state, and it has both request review and approve. So if you call request review, it returns itself because that's an invalid call. It can't be request for review because it's already published, so it's not going to go back a step. It's just going to return itself. And if you call approve, which is the transition from pending review to published, it should just return itself because it's already been approved. It's already in that final state of published. Oh yeah, I gotta add this. Let's move this over. Copy. State. As you can see, my editor is telling me when the state implementation is not being fulfilled because it's missing the approved function method. Oh, pending. And then the last state, which is published, add that here. We add the approved method to the state trait and add a new struct that implements state, the published state. Similar to request review, if we call the approved method on a draft, it will have no effect because it will return self. When we call approved on pending review, it returns a new box instance of the published struct. The published struct implements the state trait, and for both the request review method and the approved method, it returns self because a post should stay in the published state in those cases, which is what we said earlier. Now we need to update the content method on post. If the state is published, we want to return the value in the post content field. Otherwise, we want to return an empty string slice, as shown in listing 17-17. We have the code here, public content under post, return to string, self, state, as reference, unwrap, dot content, passing self. This I'm not sure if I understand. Let me read on. Because the goal is to keep all these rules inside the struct that implements state, we call a content method on the value in state and pass the post instance, that is self, as an argument. Then we return the value that is returned from using the content method on the state value. Okay. So going back up here, because they just explained some of the iffiness I had here. So we have content, which is the method that we're about to change. We're going to call the state. We're going to get it as a reference. We're going to unwrap the state because the state isn't an option. And then on the state itself, we're going to call content. And we're going to pass in post into that method. So this is going to be a method on the trait. And then the state that implements this trait will have rules for how to deal with the content, seemingly. So let's add that in. We call the asRef method on the option because we want a reference to the value inside the option rather than ownership of the value, because state is an option box dynamic state. When we call asRef, the option pointer to a box dynamic state is returned. If we didn't call asRef, we would get an error because we can't move state out of the borrowed self of the function parameter. Alright, so after reading this, I got a little better sense of what we're doing. So we're using as reference here a method on option because we need to get a reference of the box dynamic state. One reason why we need to get a reference is the parameter in content is a reference to self, but it's not a mutable reference to self. So we can't take ownership of anything. We're not changing the internal state of anything with this type of parameter. So we need to borrow it as a reference. The unwrap, which they haven't covered yet, which I believe it's just because it's an option. Actually, no, let's read onward. When we call the unwrap method, which we know will never panic, because we know the methods on post ensure that state will always contain a sum value when those methods are done. This is one of the cases we talked about in the cases in which you have more information than the compiler section of chapter 9, when we know that a none value is never possible, even though the compiler isn't able to understand that. Alright, so they're calling unwrap, which we know will never fail because of the way we wrote this. That should give us access to the box, and then we should be able to call content, which should be a pointer. The box will give us a pointer reference into state, and then call content on state. At this point, we can call content on the reference to box dynamic state. The deref coercion will take effect on the reference and the box so that the content method will ultimately be called on the type that implements the state trait. This means we need to add content to the state trait definition, and that is where we'll put the logic for what content to return depending on which state we have, as shown in listing 17-18. Alright, so now we got into the point where we're going to create the content method for the trait state. And let's look at it real quick. Content, which we have a lifetime. The lifetime is post, okay? And the string associated with it. And the default implementation is to return an empty string, which makes sense. And then for everybody else, well, that makes sense for the first two states. And then for the third state, publish, which returns the actual content, we override the default implementation and return a reference to post.content. Okay. Copy. Add that here. Has a default implementation, so none of these aren't yelling at me. That's fine. And then here we need to override the default implementation with our own. And at this point in time, we have seemingly replicated the functionality that's shown in listing 17-10. And I've said 17-10 so many times that I have memorized that it's 17-10. Moving onward. We add a default implementation to the content method that returns an empty string slice. That means we don't need to implement content on the draft and pending review structs. The publish struct will override the content method and return the value in post.content, which this we covered already. Note that we need lifetime annotations on this method, as we discussed in chapter 10. We're taking a reference to a post as an argument and returning a reference to part of that post. So the lifetime of the return reference is related to the lifetime of the post argument. Makes sense. This is true. This is why we have the lifetime. And we're done. All of listing, I was wrong, 17-11, not 17-10. All of listing 17-11 now works. We've implemented the state pattern with the rules of the blog post workflow. The logic related to the rules lives in the state objects rather than being scattered throughout post. That was tough.